We now determine the approximate area of the region using the upper and lower sum. So first, let's write the subintervals. We have four subintervals, that is from 0 to 0.25. This is one subinterval. And then from 0.25 to 0.5, this is another one. And then from zero point 0.5 to 0.75. And the fourth subinterval is 0.75 to 1.0. And when calculating the upper sum, we should consider the right endpoints and determine the value of the function at the right endpoints, which gives the height of each of the rectangle. And then the width of each of the rectangle is 0.25. And so let's determine the upper sum. So for upper sum, we consider the right endpoints. So the right endpoints are 0.25, zero point 0.5, 0.75, and 1.0. For the first subinterval, the height is given by the value of the function at the right endpoint, which is 0.25. So we find y of 0.25 times the width is 0.25. So this gives the area of the first rectangle. We then add this with the next rectangle. So here we use the right endpoint, zero point 0.5, which means y of zero point 0.5 gives the height of the next rectangle times the width of the rectangle is 0.25. So then for the third rectangle, it will be y of 0.75 times the width, which is 0.25. And for the fourth rectangle, the height is given by the value of the function at the right endpoint, that is y of 1.0 times the width of the rectangle is 0.25. So let's evaluate this sum. This is the sum that is required. Observe that we have the term or the number 0.25 in each of this product, which means we can factor out that. So we write upper sum, and this equal factoring out 0.25. We then write this as y of 0.25 plus y of zero point 0.5 plus y of 0.75 plus y of 1.0. Now let's use the function which is given as y is square root of 3x. We have y equals square root of 3x. So to determine the corresponding heights of each of this rectangle, we plug in the corresponding x value. So we write 0.25, the common factor is the common width, times the y of 0.25, replace x by 0.25. So therefore this becomes 3 times of 0.25, and this is under the square root, plus for the next one, it is under the root of 3 times of zero point 0.5 plus square root of 3 times of 0.75 plus square root of 3 times of 1.0. So we calculate the numerical value of this expression by using calculator. We first multiply these two and then take the square root and then add each of these results with the other areas of the rectangles and finally multiply by 0.25. And so when we do that, we approximately get 1.331. This one is the upper sum. We now determine lower sum approximation. So to calculate lower sum, we should utilize the uh, left endpoints of each of these intervals. That is, we should use 0, 0.25, zero point 0.5, and 0.75 to determine the heights of each of the rectangles. And then we have to sum the area of the each of the rectangles. So we write lower sum. This equals the first rectangle. We use the x as 0. So this will be y of 0 times the constant width, which is 0.25 plus the next interval, it is y of 0.25 times the width, which is 0.25, plus for the third rectangle it is y of zero point 0.5 gives the height of that rectangle times the width, which is 0.25, and for the fourth rectangle y of 0.75, this one is 0.75, gives the height times the width, which is 0.25. Once again we can factor the 0.25, which is the constant width, and then therefore this becomes when we factor 0.25, this will be y of 0, which means we have to replace x by 0 into the equation for y. So it will be under the root of 3 times of 0, plus the next one is y of 0.25. So it will be square root of 3 times of 0.25, and next one will be under the root of 3 times of zero point 0.5, and for the fourth rectangle it is the square root of 3 times of 0.75, so it's under the square root. And so we can evaluate this numerical expression by plugging the each of the square root expressions, determining that value and adding them together, and then finally multiply with the constant width, which is 0.25. And so when we do that, we get 0.898 as the lower sum. This is lower sum. Therefore, we now write approximate area of the region. We can simply take the average of these two sums, that is upper sum plus lower sum divided by 2. So let's put upper sum, which we have already calculated, which is 1.331. This one is 1.331, plus lower sum is 0.898, and this divided by 2. So we add these two numbers and divide by 2, and then we get 1.115 approximated to 3 decimal places. And so therefore this is the approximate area of the region using the upper and lower sums.